Okay, let's work on number 3. Now, number 3, 11.20 milliliter of 0.088 molar lithium hydroxide is used to neutralize 61.5 milliliter of hydrochloric acid. Now, to make things easier, let's make certain aspects of this question easier. Let's choose red. So, lithium hydroxide. We would want our formula of lithium hydroxide written up here. And then hydrochloric acid as HCl. Right, so write the balanced neutralization reaction. This is our first question. Now, what does neutralization reaction mean? Well, definition-wise, neutralization reaction is a process of when an acid and a base reacts together to produce a salt and water. So, according to the definition, if we are reacting an acid and a base, from this question, we know our acid involved is hydrochloric acid. So, we write our HCl, which is involved, and it's going to react with lithium hydroxide, which is our base component. And this is going to be producing a salt and a water. Now, the water comes from the hydrogen of the acid and the hydroxide of the base, which means the salt comes from the metal of the base and the non-metal of the acid, which means Li, lithium, and chlorine will combine together to create lithium chloride. Now, hopefully you guys all know this from previous lessons that lithium and chlorine both each have a positive one and a negative one charge, which means when they combine together, it is just going to be LiCl. And then our last but least product of water. All right, so this is our complete neutralization reaction, and it says the balanced one. So to check if it's balanced, we have 2 hydrogens on the reactants, and we have 2 hydrogens as a product. That's balanced. 1 chlorine on the reactant and 1 chlorine on the product. That's balanced. 1 lithium and 1 lithium, balanced. 1 oxygen balanced. 1, and we already did the hydrogen from prior. Now, here, part B, it says calculate the concentration of the acid. Now, there haven't been much information that's given to us, but we have enough information to figure this out. We know that this is going to be a neutralization reaction, which means, and according to this equation, for every 1 mole of hydrochloric acid, 1 mole of lithium hydroxide is used, which means our reactant that is given to us up top, 11.20 milliliter of 0.0088 molar lithium hydroxide, and 61.5 milliliter of hydrochloric acid, they're both going to be completely used up and create our salt and water. Now this means however amount of moles of lithium hydroxide we have, that we start with, we're going to have the exact same amount of hydrochloric acid, moles of hydrochloric acid, because we need the same amount of moles to neutralize each other out. So, from our given information though, let's figure out how many moles of lithium hydroxide we have. So, lithium hydroxide, and then I'm going to start our calculation for this. Well, we're still going to be using the equation molarity equals moles over liter, right? So the number of moles of lithium are going to be our X. So our molarity starting with 0.088 molar equals the number of X in terms of moles, and we're going to have our volume. Now, it's going to be very easy for you all to mistake that volume 11.20 milliliter to go directly down here. But notice the unit of milliliter and then our unit of liter. We do have to have it unit specific, which means we have to convert milliliters into liter. Now, we all should know that there are 1,000 milliliter in 1 liter, which means 11.20 milliliter. In order to convert it into liters, we just have to divide it by 1,000 milliliter for 1 liter, which then we can divide those units out, leaving us the units of liter. However, we also have the unit divided by 1000. So we should end up getting 0.01120 liters as our volume, which then, because that is our volume, we can now plug it into our equation right here. We can plug that in as 0.01120 liters. Now, just like the equation that we worked on from part 1 of the video, we multiply each side by volume, and we know that the units will cancel out for moles. So when we do the 0.01120 liters multiplied by 0.088 molar, we are going to get the number of moles. And when we do this calculation, we should hopefully get 9.856 times 10 to the power of -4 moles. All right. Now, this is going to be moles of lithium hydroxide. However, because this equation is a 1-to-1 ratio, however amount of lithium hydroxide used in terms of moles should be the exact number of moles of HCl used. So we can equivalently write down that 9.856 times 10 to the power of -4 moles of HCl was also used in this equation. Now, if we know the amount of moles of HCl and we know the volume, which also we have to convert, so we're going to do that conversion from milliliters to liters, which should end up in 0.0615 liters of HCl. Okay, now that means we now know the moles of HCl and we know the volume of HCl, which then we can come to the gathering circle right here and put down 0.0615 liter HCl, and hopefully this was not written as a capital, divided by, oops, my bad, this was a mistake. Opposite, we have to have the moles on top, so 9.856 times 10 to the power of -4 moles over 0.0615 liters, and these are all about the HCl. So when we get our concentration, which happens to be 0.01603 molar HCl. This is our final answer for 3B. All right, moving on to number 4. Number 4, 18.2 grams of solid NaOH is dissolved in 0.250 liters of water. The molar mass of sodium hydroxide is 39.99711 grams per mole. Now, A, what is the concentration of the solution? Now, as simple as it is, we need to use the equation. What do we know that associates with concentration is molar concentration is equivalent to moles over liters, which just means that we have to do this calculation. I'm going to switch my pen to a slightly thinner one. Okay, so we're going to use 18.2 grams of NaOH. Now, here's the thing. We have our volume component. We have our liters. And this molarity right here is our X component. However, we do not know what the mole is currently, but we have been given grams, which means all we need to do is convert grams into moles. And by this point, you should know that in order to convert from grams to moles is by dividing it by its molar mass or multiplying it by the moles over molar mass. So we have 1 mole of NaOH, and that 1 mole of NaOH molar mass is 39.99711 grams per, well, just grams, because the mole goes on the top. right? And this is for the NaOH, sodium hydroxide. Now we notice that the units can divide each other out, giving us the number of moles right here. Sorry about these squiggly lines, but this ends up giving us 0.4550 moles of NaOH, sodium hydroxide. Now we know the mole value, and we can just plug it in. So molarity of sodium hydroxide is equivalent to, let's see, 0.4550 moles over 0.250 liters. And this gives us the final value of 1.82 molar sodium hydroxide concentration. All right. Now, what is the pH of the solution? Now, here's a tricky question right here. It's asking for the pH. Now, if sodium hydroxide is dissolved in water, you have to understand we are to write the dissociation of sodium hydroxide, which is, what is going on with the screen? All right, so sodium hydroxide, NaOH, and we are dissociating it to Na plus and OH minus, and we know it's a single-headed arrow because it is a strong base. Now, when it's asking for the pH of the solution, if you look at this question, it's this dissociation equation, we don't have a hydrogen ion component at all. We only have a hydroxide component. So what does that lead us to do? That means we have to find the pOH using the OH concentration, and then from there we can figure out our pH. So we can refer back to the equation and saying that the negative log of hydroxide ion will give us the value of pOH. So let's do this. So we already know that our concentration from above of the hydroxide, and because this is a 1-to-1 ratio, we know that the concentration of the sodium hydroxide and the hydroxide should be the same. So we put in negative log of 1.82, and this gives us a value of negative 0.2601. Okay, now this you have to understand is the pOH value as negative 0.2601, which means that we are going to have to find the pH from this. But of course, we know our simple equation pH plus pOH equals 14, which means we just have to plug this into our pOH value, and we can get our pH value as 14.2601. And this is our final answer.